Well, good morning, everyone. My name's David Bean, and I'm the Solutions Manager here at Mitsubishi Electric Automation Systems in the UK. And welcome to another in our series of We Know webinars. And today we will discuss what we know about smart factories for SMEs. If you'd like to ask any questions during the webinar, you can do so using the control panel on the right. We'll answer as many questions as we can at the end of the webinar, and any that we do not cover, we will respond after the event via email. And on that note, I would like to hand over to Chris Evans.
Thank you, David, and welcome everyone. My name is Chris Evans, and I'm the Marketing and Operations Group Manager at Mitsubishi Electric. And there I am. And before we start, I'd just like to remind you, as David said, that this session is part of a series of webinars under our We Know banner, and you can revisit the recordings of the previous sessions on our website. And just to remind you what they are, we started with cybersecurity for operational technologies, then moved on to edge computing technologies. We then covered collaborative and cooperative robots, and last week we tackled predictive maintenance. So this session today will be available as a recording, as well as those to revisit or share after the event. And next week we have a session on compact control and safety for OEM machines. And into June, we look at extended functionality of the modern variable speed drive and also helping manufacturing back to production. Okay. So today we're going to look at smart manufacturing and how it can be applied to any enterprise, regardless of size and age of plant. So we'll look at an overview and we'll ask the question, why do it at all? We'll also look at what I would call smart manufacturing utopia. And we'll also consider what often is the reality against that. We'll look at changes that face us and challenges that face us to implement smart manufacturing to an existing plant. And we'll look at how to set a clear plan in place to achieve that. We'll also look at some real life examples of some quick wins and how they help us start our journey towards smart manufacturing. So over the years, many terms have been used to describe this process, and you can see some of them here. And some of them have become very familiar to us, and others we almost avoid using now. I think Industry 4.0 potentially falls into that category. But for the purpose of today, when I refer to smart manufacturing, I'm in fact encompassing all of these to a lesser or greater extent, as they actually underpin the whole process. So let's consider this question, why do it at all? We often hear, my plant is running, we generally hit our targets, it just sounds like extra cost. But I think the business benefits of adopting smart manufacturing strategies are very clear. We'll be operating at optimum efficiency and utilization. We'll have total visibility of plant operations and total plant control. We have flexibility and we're agile in responding to demand. We will increase productivity and with minimum waste, whilst delivering better quality products, and ultimately we'll be more profitable. So it's clear that going down this journey, along this journey towards the ultimate goal of smart manufacturing is clearly going to bring some benefits to us. So let's start with the ideal model. If you like, I'm calling this smart manufacturing utopia. This is our smart factory, completely integrated to the factory ecosystem. And this reaches from on-demand supply of raw materials, efficient energy supply, efficient sustainable production and green manufacturing, through to distribution and linked to customer demands. And that is our ideal. And to deliver that, our ideal factory topology would look a bit like this. So most of us are familiar with the plant level, and that would consist, of course, of automated assets with good communication networks. This could equally apply to an actual manufacturing factory plant as to a process plant or water treatment works, anywhere where we have a collection of assets networked together to produce something. If we look at the other end of that topology, we introduce the enterprise or IT level. And of course, at that level, it can consist of centralized servers and or cloud services. And this is where, at this enterprise level, we can do analysis and manage the business and ecosystems. So the bit in the middle is what has now become known as the edge computing layer. And this forms the bridge between the plant and the enterprise, providing data collection, data management, and advanced analysis and diagnostic capability. And this can include, of course, artificial intelligence and advanced analytics. And all that is interfaced with the plant in real time. And if you'd like to find out more about the technologies that underpin that edge layer, then please refer back to our seminar and our webinar that I mentioned earlier on edge computing technologies. So as part of Mitsubishi Electric's delivery mechanism for the totally integrated factory, we operate a partnership called the eFactory Alliance. The eFactory Alliance brings together complementary integrated technologies to provide the best-in-class solution for our customers. You can see that it operates on a pan-European and global level. And I'll come back to this when we look at some of the practical examples later on in the presentation. So in order to achieve any of that, fundamentally, we need to create information from the data that exists within our assets on the plant floor. As it says, if you don't know what's going on, you don't know what's going wrong. And we'll start by measuring things at the plant level. At this stage, of course, the information that we get is just data, numbers with no substance or meaning. It's an interesting fact that it said that 70% of all the data you acquire is already being measured at the machine or plant asset. It just may be that you're not doing anything with it, but it's a lot easier to go and get it rather than have to make program changes to an existing asset. Although, of course, if what we need is not being made readily available, then some engineering effort will be required to get out what we need. So the next stage is to collect it, and we'll look at that in more detail shortly. However, at this stage, it's still data. At the next stage, we'll aggregate it. We'll select what we want, we'll cleanse it and change it into information, data with real meaning and context. Qualified to units that actually mean something to us all. From there, we can do some real analysis on this information, which can be done either at the asset level controller or in fact at the edge layer controller. Once that has been completed, actions can be taken which maybe be as simple as an operational change, right up to complete machine learning analysis. This cycle, of course, is repeated constantly. So that's our process for getting our data and turning it into information. So it's clear that if we've got one of these, a greenfield site, the technology already exists today to create one of these, our smart factory. And a new plant with a suitable budget, it's easy to create my utopia scenario of smart manufacturing. But actually, the reality, perhaps in many cases, looks like this. So we're faced with existing plant that may have been around for some time. And those plants will have evolved over time to deliver what the business needs to achieve in terms of production targets. Efficient use of space, plant-wide automation, and a data management strategy may or may not exist. Maintenance is likely to be reactive or at best preventative, and therefore adapting an existing plant to embrace the principles of smart manufacturing can offer tough but not insurmountable challenges. Fortunately, there seems to be a willingness to at least consider starting this journey. Its results of surveys have shown that 85% of businesses say that they understand the potential of smart manufacturing. Unfortunately, only 10 to 15% have detailed strategies in place to deliver it. Equally, 87% of businesses say that predictive maintenance driven by real-time data is important. But again, only 9% measure operating efficiency in real time. So if there's an understanding and an appreciation, why is it that businesses in general are slow adopters, especially on existing plant. Well, this is our road to smart manufacturing. As you can see, it's nice and straight, although maybe the road sign says something slightly different. And we have to recognize the obstacles that we need to overcome. And it could be that we have an amount of legacy systems on site. Some of these may be obsolete or not capable of delivering what we need. There may be no network infrastructure in place, so how will we collect the data from the plant if that's not there? There may be little or no budget available. The plant may be risk averse and resistant to change. There may be little resource available to tackle any projects, and no implementation plan exists. And one which is often forgotten about, actually, is cyber attack. Now, cybersecurity is clearly a very, very important consideration. And as we converge the enterprise level with the operation at plant level, if left unchecked, will naturally increase the threat of cybersecurity and cyber attack. What's important to recognize? It's important to recognize that and understand the risks and take actions to mitigate the threat. It's all too easy to forget about cybersecurity, but a smart factory needs smart security. Again, referring back to one of our previous sessions, we detail this in a lot of depth, and we look at cybersecurity for the operational technologies at the plant and above, and we explore how to attain compliance with IEC 62443. So again, if you want the greater detail, please refer back to that previous session. So the last few slides, I've sort of painted a relatively negative picture, but another way of interpreting that is to fully understand where you currently are and to build from that. So in answer to the question, how do we get there? It's by taking small but measured steps. So planning is absolutely vital. We have to devise a deliverable plan. We can dream big, but start small. Scale the plan to match the size of the operation and available budget. I've previously mentioned several times already that without data from the plant, we have nothing. So first automate and visualize the plant, and then worry about the detailed analytics and artificial intelligence later. So a successful smart manufacturing implementation is achievable in small steps, providing that the end goal is clear. So let's look at this plan in a little bit more detail. The fundamental question that we need to ask is, what are you, the manufacturer, trying to achieve? Communication and dialogue with the plant managers is absolutely key. What are their key drivers? Is it to become 15% more efficient, or is it to cut waste by 20%, for example? But this knowledge is absolutely vital, and it will form the basis of the plan. Because if the plan does not deliver against these key metrics, then it's failed. Where are the problem areas or pinch points? All plants will have them. It's just honing in on that and trying to find a solution. What automation currently exists? Fundamentally key to gathering the information or the data to turn into information that we need. And coupled with that, of course, is that what network infrastructure exists at plant level. Where are the quick wins? The quick wins are what we're really looking for. And hopefully the quick wins line up with the problem areas, because this offers us the greatest opportunity. So if that was the discovery plan, part of the plan, then this represents a delivery part. So we have to develop that strategic plan, and we have to have key goals and targets along the way. It is possible to implement this in a staged approach, but let's always have an eye on the final goal. And timescales will have to be managed and be realistic. And again, it's directly related to the current automation and network infrastructure that exists on plant. And if those elusive wins can be found, quick wins can be found, then this represents a great opportunity to deliver return on investment periods, short return on investment periods really, for a manageable investment. And as the plan is implemented, it's really important to keep the dialogue going all the time, discuss progress, achievement of the goals and key metrics before progressing to any future stage. And we'll revisit that in our practical example in a moment. One of the other key challenges that we meet is actually at plant level. So this could be a typical production line. It's got 4 machines, 2 of which may well have Mitsubishi automation equipment on board. And if there's no site standard for automation, then it's likely that the scenario will be like this, with a hybrid of automation vendors present. Now, for many years in the automation world, we've adopted open network standards. So this enables communications between disparate vendors to be achieved, albeit with a level of engineering input. And that, of course, could enable the connection of our data from our individual machines back to some sort of data concentrator or manager. If we expand that across the whole production area, then this architecture gives us great flexibility and scalability. At data manager level, we can carry out local processing and data management at that point, which we can then visualize either locally or at plant-wide level. We could equally introduce an edge computing layer, which would give us greater analytical power and could include artificial intelligence and advanced analytics, like we said before, all done in real time. And also allow us to flatten the architecture, removing some of the layers if we wanted to. Now, this step could also come much later in the process. Enough intelligence will exist at the data manager level to meet our initial needs more likely than not. Eventually, we could connect to the enterprise level, and then we're looking at local or cloud-based servers. This could be achieved at either the data manager level or at the edge. This creates a very flexible architecture to suit the requirements of any of the projects we tackle. And there's our cloud. So remember my utopian slide of that nice, clean, brand new factory. Well, when we engage with manufacturers who want to become and begin their journey towards smart manufacturing and they're owners of existing plant, what we normally get presented with is something more like this. And usually this statement. Now what you see here is a typical plant, existing plant with lots of machines, mostly automated, no site standard, no automation level network infrastructure existing. So what I'd like you to do now is take you through a real life scenario with a typical UK based manufacturing plant that had great ambition. So we're going to start by just getting a little bit smarter. So let's revisit our plan. If you remember, our first question was, what is the manufacturer trying to achieve? Well, in this particular case, it was improved efficiency, reduced waste, reduced work in progress, and be more profitable. So it lined up a lot with our original statement back at the beginning of the presentation. Where are there problem areas or pinch points is the other question. Now, a number were identified, and we had to understand how this affected overall efficiency. And it was about this time that I remember being at a meeting with the production director, and he was outlining some of the problem areas. If you can imagine that the final product here is an assembly of lots of components. It has an outer casing on the product, so it has metal panels, left-hand panels, right-hand panels, etc. And they manufacture the panels via some operator controlled hydraulic presses. It normally takes the operator about 30 minutes to set the tooling up to make, for example, a left-hand panel. So he was describing this process to us, and he said it takes 30 minutes to set up the tooling, and the guy comes along on a forklift truck with his pallet of blank plates, and there are 500 in the pallet. And he said the operator makes me 500 left-hand panels. To which we said, well, okay, yeah, and so he says, only wanted 200. And we still really didn't see the problem. And we said, well, okay, well, you have 300 extra panels that you don't have to make next time. And his comment was, I don't have anywhere to put them. And that's this issue that they have here of work in progress. His whip store was of a certain size. And if you imagine this assembly has many different components in it, if you overproduce on all of your components, the problem is storage of the excess. And that for me encapsulates the difference between a manufacturing plant and a smart manufacturing plant. The guy on the press had the best intentions. He was given 500 blank plates. He made 500 left-hand panels. A smart plant would have been in total control of that process. It would have been reacting to inventory control. It would have been reacting to customer and order demand, and it would have made that whole process more efficient. And that was a good example of what we're trying to do here, I think. So again, we asked the question, what automation currently exists? Well, most of the machines were automated, but as standalone machines, because there was actually no plant level network infrastructure in place. The only networks around were the IT level networks. And the quick wins, some manual assembly areas were defined and identified as possibilities. So our delivery against that plan, which was develop our strategic plan. So many meetings occurred on site, lots of discussions. And eventually an overall plan was developed and the milestones agreed. And it was to be tackled in manageable stages so that budgets could be allocated and planned accordingly. Developed realistic return on investment plans and timescales to deliver. That was important. And this about the quick wins and short ROI periods again is target a pinch point that delivers good return for minimum investment. That was the goal, which of course demonstrates that the strategy works. And again, constantly communicate during this process. So if we were going to try and find our elusive quick wins, this is an interesting statistic. It says that up to 80% of manufacturing faults are caused by human error, which if the production process includes manual assembly, then that should offer us some real opportunities to get some quick wins and deal with this low-hanging fruit, if you like. Okay, so as part of the assembly of the overall finished product, it included a manual assembly of an electronic cassette. So this consisted of a number of PCBs, which had to be mounted together with bushes, pillars, washers, and screws of varying length, and cable assemblies fitted. It was clearly possible to fit the wrong screw into the wrong bush, if you think about a short screw into a deep bush, which may not be discovered until the product line is actually in use. So before anything was done, the unguided manual process resulted in up to 15% reworking. So the first thing to do was to automate the manual process by using a Mitsubishi Electric guided operator solution. So the guided operator solution basically guides the operator through the assembly process by controlling the supply of components via a series of automated bins and giving visual indication of which part to pick next. So this first part of the process gave an opportunity for a manageable investment to tackle a known pinch point problem area. Okay, so what did it actually look like in practice from a system point of view? Well, the first line was initially installed as a standalone system consisting of the GOS, the guided operator solution, and a local HMI to display bill of materials and operating instructions. This already was an immediate improvement on the laminated sheets that we used before and were placed above the assembly area. And because of the success of the first phase, it was rolled out to a second assembly area. And it was also clear to the site managers at that point that if the systems were connected to the enterprise level, then multiple bills of materials and product variants could be simply downloaded, which made the enhanced system extremely flexible. Of course, the system has the capacity to expand out still further. And for me, this is a classic example of how systems can grow from what was initially a proof of concept to a fully integrated system implemented over time, but with the vision of the end goal in place from the start. So what were our success factors? Well, once the guided manual operating system had been put in, this resulted in less than 1% reworking of the product, which clearly improved product quality and enhanced the brand reputation, fewer failures in the field. We improved our overall operational efficiency. And of course, it reduced the operator training time. And this is a softer benefit, but one that maybe we don't always consider. But the operators were under less stress. They made fewer mistakes. And so the result of that was a measurable reduction in sick days over a period of time, which is maybe something that you wouldn't necessarily consider as a benefit when you start out. So the power of this proof of concept activity is really, really good. I mean, it convinced the production manager in this plant that automation works and delivers. So where else could we find some quick wins? So we all know that the loss of critical plant assets costs downtime. We also probably know that predictive maintenance can drastically improve this situation. And again, we could take a staged implementation approach to that activity. Start with a proof of concept trial, which can show real value in how the system would deliver results. So here's an example. I think all manufacturing plants will have critical plant assets, which if lost, of course, due to failure, will have a huge effect on the operation of the business. In this example, we can see a large blower motor. It doesn't have a standby option. And at best, probably maintenance for this asset would be preventative and scheduled at suitable intervals. A predictive maintenance solution can deliver information about the machine condition. It recognizes early signs of damage and failure. And of course, we're able to perform data analytics on it to predict those failures in the future. Now, Mitsubishi Electric has developed a solution, one of our eFactory Alliance partners. I mentioned eFactory Alliance back at the start, and our partner Schaeffler, and together we call this our smart condition monitoring solution. And this solution has been used by many different companies now as an intelligent predictive maintenance solution using the Schaeffler sensor technology and the Mitsubishi integrated automation. And again, if you'd like more detail on this, our webinar on predictive maintenance goes into this in some depth. But predictive maintenance solutions can be implemented as a standalone solution or as part of a fully integrated system. Once again, we can start as a proof of concept initial trial to prove the values of the generated data. And again, for a relatively low investment, we can deal with a critical asset and therefore give high returns. Now, hopefully you can see from these two real world examples of how to identify quick wins and solve problem areas and give an indication of how to start the journey in small steps. Now, before I sum up, I'd just like to give you a heads up on next week's system webinar, which of course is on compact control and safety for OEM machines, again on Thursday and starting at 10:30. So, if you remember this slide, which I put up a while ago now, which showed all the blockers on our road to smart manufacturing. Now, with direction, things look a lot clearer. And let's look at our milestones here. Our goals and key metrics are fully understood. And that leads us to the development of a strategic plan and a proof of concept trial agreed. After that proof of concept trial, the return on investment is proven, which then leads to the agreement of the first phase implementation. At that stage, there's enough confidence maybe in the process to plan for the second stage. Once that first stage has been completed, a review of the first stage delivers the required success factors, and that leads to the development of the second phase implementation plan, and so it goes on. But as you can see, breaking the journey into manageable steps makes the whole process achievable and affordable. So before I answer some of your questions, I'd like to leave you with this. We should understand and have eyes on our ultimate goal. Our journey can be adapted to suit any size of operation. This is not just the domain of a large organization or new plant. I hope you can see that now. And it is possible to make this journey in incremental steps. And with the right approach, everything is possible. I'll leave you with that one. So we'll look at some of your questions from the chat room now. If I can just bear with me a second. Okay, so, all right. Someone may have asked the obvious question. On average, how long does it take to become a smart operation? That's a good question. Now, as I hope I've illustrated, many factors will determine the length of that journey. I think, as I've also said many times, a lot of that will depend on the level of automation and network infrastructure that already exists in order to get that vital data and information from the plant. So if your plant's already well automated with a good network infrastructure, then the problem is usually not getting the data, but how to handle the data that's available to you. But if your plant resembles more like the plant in my example, then the journey could take several years. But I think implementing a well-planned stage approach will deliver results and return on investment. The progress may be slower, but operational improvements will be seen along the way. So I hope that sort of deals with that one. Oh, another one here, okay. At the beginning, you mentioned we no longer like to talk about Industry 4. Why? Okay, so this subject has been discussed for many years now, and many articles have been written in the trade press. At the beginning of that period, the big new term was Industry 4.0, and it got everyone excited, I think. There is a danger, of course, of overuse or saturation of any single term when we're dealing with this type of process. I think today we tend to talk more about digitalization and of course, smart manufacturing. But in my defense, I think I also said at the beginning that all the terms that we put up on that slide underpinned smart manufacturing, and actually the principles of Industry 4.0 at the heart of all this process. So I hope that's dealt with that one. The rest of your questions will answer by email after the session. So I'd just like to thank everyone for attending. And of course, we at Mitsubishi Electric would be happy to engage with you to discuss your requirements about your journey towards smart manufacturing.